The next example out of 3.4 asks us to use transformations to sketch. Use transformations to sketch when y equals x cubed is transformed to y equals negative 3 times 2x plus 4 cubed plus 1. So hopefully we have some sense of what y equals x cubed looks like, having drawn that one a whole bunch of times. And now we need to do all of these things to it. So the first thing I would do is describe what these things actually are, what each of these parameters does in this equation. The first thing is the negative. That's going to reflect this graph about the x-axis. So a very rough sketch is going to be turning this graph upside down. Now what is the 3? The description of that one is a vertical stretch by a factor of 3 about the x-axis. So this graph will get 3 times as tall or 3 times as steep. Again, roughly sketched, something like this. We'll do a much better job at the end. Now I look inside the big brackets at the 2. Having that 2 inside the brackets there means that it's being done to the x. It's a horizontal stretch by a factor of a half about the y-axis. Everything will be now half as far from the y-axis. So it actually does a similar end result to the last one, which makes it tighter or steeper. Now the last ones to describe are the translations. By this point you guys are pretty good, it seems, at describing translation. So the x plus 4 in the brackets is going to move this graph 4 units to the left. 1, 2, 3, 4. So this steep cubic function 4 units to the left, and then vertical translate 1 unit up. Hard to picture, but let's do a little bit better job of this drawing. To get a bit more accurate sketch, we're going to look at some actual points on the original graph, and we're going to compare them to what happens when we do transformations broken into pieces here. So the table that I've made looks like this. One nice point on the original graph is the point 0, 0. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. We can follow some negative ones as well. Negative 1, negative 1, negative 2, negative 8. So the first transformation I've got here is horizontal stretch by a factor of a half. Does nothing to the first point because of the 0, but every other coordinate x is multiplied by a half. So I've got a half comma 1, I've got 1 comma 8, I've got negative a half comma negative 1, and negative 1 comma 8. So notice corresponding points have no change in the y coordinate. X coordinates are all in half. Now we're able to do the reflection and the vertical stretch at the same time because they both affect the y coordinate. They're going to multiply all y coordinates by negative 3. So 0, 0 stays at 0, 0, but this next point, negative 3. Next point, negative 24. So we've got some points, and finally the last thing is to move them 4 to the left and 1 unit up. So we have some exact points that we should be able to, if given some graph paper, plot here and get a really good picture of this thing. So again, 4 units to the left, 1, 2, 3, 4, positive 1. This was the point that was originally going through the origin. Now if I plot a couple of these others, go to negative 3.5 comma negative 2, I've got a point over here. If I go to negative 4.5 comma positive 4, I can get a sense of what this graph is doing. I didn't draw a large enough graph, or graph with a scale that's going to allow me to put these points that are way down at negative 23 and up at positive 25, but I think this is good enough that you can see where this one is going. So you're doing a graph for marks, a good idea to put some points labeled on it so anybody looking at it can see that you know what you're doing. And that would be a good final graph for this transformation.